Hello everyone, my name is Sai Teja from EEE department. Today, the talk presentation is about the separation of independent and dependent source using couples. In this presentation, we can see the what is independent and dependent, how are different between the independent and dependent, and separation of independent and dependent source using couples. Separation of independent and dependent source using couples. The concept of couples can be applied to model independence structures between different sources or components in a system. Here, a general outline of how you might approach this. Identify random variables. In an electrical circuit, various parameters such as resistance, capacitance, inductance, and voltage can be considered as random variable. Identify which variable are considered independent, which are dependent. In this, we should find independent sources and dependent source. Independent source means which give energy to dependent source. Modeling independent source. For independent source, you can assume that the variable associated with this source follows independent distribution. The joint distribution for independent source can be modeled using a product couple. This means that the overall joint distribution in the product of marginal joint distribution for independent source can be modeled using a product couples. This means that the overall joint distribution is the independent. You can assume that the variable associated with this source follows independent distribution. This means that the overall joint distribution is the product of the marginal distribution of each independent variable. Modeling dependent source. For dependent source or variable couples that capture the specific independence structure should be used. The choice of couples, example Gaussian couple, T couple, etc., will depend on nature of the independence among the variables in the circuits. Combine independent and dependent components. The overall joint distribution of variables in the electrical circuit is a combination of the product couples for independent source and the couples that models the dependence among the product couples for independent source and the couples that model the independence among the distribution of variables in the electrical circuits in a combination of the product couples for independent source and the couples that models the dependence among the dependence among the dependent source. Parameter estimation. Estimate the parameter of couples based on observed data or known characteristics of the circuit's components. Simulations and analysis. Once you have the joint distribution, you can simulate random samples to analyze the behavior of the electrical circuits under different conditions. The joint distribution, you can simulate random sample to analyze the behavior of the electrical circuit under different conditions. This can be particularly useful for reliability analysis, risk assessment, and sensitive studies. It is the risk assessment, realizability analysis, and sensitive studies. These steps involves understanding the statistical properties of the variable, calibrating the couple's parameter accordingly. Validation. Validate the model by comparing validation. Validate the model by comparing simulated results with actual measuring or known as behavior of the circuit. The behavior circuit is the validate the model by comparing simulated results with actual measuring. We should compare the models by the actual measuring. Then it is called behavior of the circuit. Adjust the models and couples parameters as needed to improve accuracy. We should adjust the models and couples parameter to improve the accuracy. Applying couples in electrical circuit analysis may be more common in scenarios where uncertainties and dependence among circuits parameters play a significant role, such as in reliability studies or when assigning the impact of variations in components characteristics on circuits performance. Depends among circuits parameter play a significant role, such as in reliability studies or when assigning the impact of variations in component characteristic circuits performance. Be more common in scenarios where uncertainties and dependence among circuits parameters play a significant role, such as in reliability studies or when assignment the impact of variations in compact characteristics on circuits performance. Keep in mind that the success of approach depends on the appropriateness of the chosen couples and the accuracy of the assumed distribution for the circuit's parameter. Reliability analysis scenario. Consider a complex electrical system with multiple components, resistor, capacitor, etc., each having uncertain properties due to manufacturing variation. The goal is to assess the reliability of the overall system. We should consider a complex system and put multiple components of capacitor, resistors and inductors. Applications. Assess the probability of system failure under different conditions. Optimize components tolerance for improved reliability. Parameters estimation and calibration. Challenge. In practical application, obtaining accurate parameter estimates can be challenging, especially when the data is limited. In the practical values, there is a difference in 0.1 or 0.2 when you do in theory. Approach. Using historical data if available to estimate couple parameter. If no historical data is available, conduct experiment or simulations to observe the joint behavior of variables. Calibration may involve adjusting couple parameter to match observed. Calibration may involve adjusting couples parameters to match observed coloration or other relevant characteristics. Circuit design optimization. scenario. In circuit design, optimizing for performance, power consumption, or other metrics often involves dealing with uncertain parameters. Approach use couples to model independence between design parameters. Optimize the design by considering the joint distribution of parameters achieve desired performance characteristics. Conclusion. Applying couples in the theme of electrical circuit requires a thoughtful consideration of the specific characteristics of the system, the nature of uncertainties, and the desired outcomes. It often involves a combination of statistical analysis, simulations, and energy expertise to create models that accurately reflect the behavior of electrical systems. Thank you.